dimension of Planck's constant. We have to find the dimension of Planck's constant. We have to find dimension of Planck's constant. The energy of photon vibrating with frequency nu. The energy of photon vibrating with the frequency nu is directly proportional to its frequency. The energy of photon vibrating with frequency nu is E proportional nu. Therefore, E equal h nu. E is equal to h nu, where nu is the frequency of photon and h is the Planck's constant. Therefore, E equal h nu, which is the energy of a photon, where h is the Planck's constant. H is Planck's constant. H is Planck's constant, which is related to energy of a photon, and the value of Planck's constant is 6.626. 6.626 into 10 to the power minus 34 joule second. H is equal to 6.626 into 10 to the power minus 34 joule second. Joule second. Therefore, H is equal E by nu. H is equal to E divided by nu. Therefore, dimension of H is equal to dimension of E divided by dimension of nu is equal to dimension of E is ml square t to the power minus 2 divided by dimension of frequency is t inverse, where the unit of frequency is second inverse. The unit of frequency is second inverse, second to the power minus 1, or hertz. That's why the dimension of frequency nu is t to the power minus 1. We get the dimension of h as equal ml square t to the power minus 1. ml square t to the power minus 1. The dimension of Planck's constant, that is dimension of h, is equal to ml square t to the power minus 1. That is the dimensional formula of Planck's constant. H is equal to ml square t to the power minus 1, which is the dimensional formula of Planck's constant. Dimensional formula of Planck's constant. The dimension of H is equal to ml square t to the power minus 1.